Suppose you had a Bible, very valuable Bible, and somebody asks you for a copy of the Bible. So what you do is you say, well, I can't give you the Bible, but what I can do is I'll photocopy the pages. Now, it's a long process, of course, so what you do is you start photocopying the pages, and you take each page and you fold it up and you put it in an envelope and you address it to the person and you put it in the out tray, and you keep doing that as you photocopy the pages. Postboy comes by, collects what's in the out tray, takes it down to the post room, and it disappears into the postal system. Meanwhile, you're still copying the Bible page by page, and you're sending it off one page at a time in the envelopes. The guy at the other end, receiving the envelopes, not necessarily in the same order that you sent them, opens the envelope, takes out the page, looks at the page number, reassembles the Bible in the correct order, and now he's got a photocopied version of the Bible. And of course the postal system in the middle didn't have to carry a whacking great precious Bible. What it carried was little pieces of the Bible, chunk by chunk, packet by packet. That's what packet switching is. You take your original data stream or your data set and you chop it up into small pieces, you transmit that through the network. Each piece is separately addressed, finds its own way through the network, recipient gets it, puts it back together into the original block or stream or whatever. That's basically what it is. That's what it is. Why do you do that? It's to do with queuing. If you have packets arriving and they're all little pieces, then you can very quickly sort them and send them on their way. But if you've got a whacking great message that's stuck being transmitted down the line, then you've got to wait for that to finish before anything else can happen.
And it was interesting that Donald Davis, who started all this, observed that in the same way that large mainframe computers sliced up their programs for the benefit of the operators, why couldn't we slice up the communication mechanism between the terminal and the computer in much the same way, and basically for the same sort of reasons? Because what you needed to do when operating these programs every so often was to put in a very short message, which was a command or something. And there was a real danger that if you use the telephone line in the traditional way, that this command would be delayed because there was a long message on the line. So the origins of packet switching were really rather similar to the way that the batch processing mechanism developed, in that the communication network was sliced up in much the same way in packets.
And we actually built the network, and it went live in service, I think, at the beginning of 1970. By the beginning of the 60s, the telephone networks around the world, particularly in the USA, I guess, had become very big. There were millions of telephones in service using the technology of the day, which is an analog circuit switch technology. And we were coming along suggesting something quite fundamentally different for computers. And there was resistance to that idea, simply because it didn't fit with what was already deployed in the ground. And the idea of using very fast lines for terminals was something which was anathema, because they were used to using very slow lines for telephones.
Post Office Telecoms, and they got their business market set on, what is it, 4 kilobit lines for voice. And along come these bunch of guys who know nothing at all about telecommunications. But we had no baggage. Because we didn't know anything about telecoms, we had absolutely no baggage. So we just started from scratch and said, this is a system that will work.
The first time that one of our American friends came over from ARPA to visit us, and I showed him I'd got a VDU unit, glass screen keyboard unit, and I connected up the scrapbook, and I hit the button, and the whole page appears in less than half a second to get a whole page up. And he was just gobsmacked, because he was used to seeing the stuff crawling onto the screen like this at a few hundred characters a second. The ARPA project was just starting at the same time, and the network to connect those computers together was something they were only just about considering. Now, their idea was to use fairly low-speed lines, because that's all that was available from the telephone company. So when our paper, which was actually published in the same session as their paper, said, no, don't do any of that slow telephone stuff, use 1.5 megabits. And they were going, oh yeah. But within about a year, they had designed a system. It was actually built by a company called Bolt, Baranek and Newman, and they had designed a system. And if you look at their original designs and you look at our network paper and you go, I think they probably copied what we did. ARPA network at that time was 3 or 4 nodes, but if you look at the ARPA map of about 5 or 6 years later, it's got like 50 nodes on it. I mean, it covered the whole of US, but it was also extended to Europe, and Peter Kirstein's group at University College London had a connection to the ARPA network, and we got a connection to his interface and to our network. So we were then connected. So we had the first situation where 2 networks were connected, and there was inter-network traffic.
Yes.
Between the networks. And the idea of the computers connected together became the idea of an internetwork, which eventually became an internet, which eventually became the internet, and everything flowed from there. But of course the thing we have to remember is that the underlying technology for all of this is packet switching.
Yeah.
Anybody who has at home has got a router connecting to their broadband internet service and has more than one computer sharing that hub is using Ethernet, and that little hub that they've got is a packet switch, and in fact what they've got in their home is a microcosm of what we built at NPL.